My name is Huda Alghamdi. I'm from Imam Abdulrahman bin Faisal University from Saudi Arabia. This is a study made in the field of water treatment using Chitosan as a biopolymer. So it is an eco-friendly treatment via adsorption process. What we did is that we modified Chitosan chemically using 3 kinds of benzaldehyde to gain more robust polymers to remove the cobalt and nickel ion from water. What we did here is this is Chitosan, and this is the first monomer we added to the Chitosan, to the matrix of Chitosan. So we achieved the Schiff-based compound polymer, and this give me more stable and more robust polymer. Okay, so the first polymer we add 3-hydroxybenzaldehyde, and the second one we add 2,3-dihydroxybenzaldehyde, which has two groups of hydroxyl group. So these will contribute to catch the metal ions perfectly. And actually, this polymer achieved the good result. The last one is 3,5-ditertiary-butyl 2-hydroxybenzaldehyde. We added to the matrix of benzaldehyde, so the carbonyl group insert into the NH2, and we achieved the imine group, as you see here. Why we chose this monomer? Because we thought that maybe the tertiary butyl groups here will induce the long pair of electrons, and that may catch the metals very good. But what happened here is the second polymer give me a strong and stable complex with the metal ion. Okay, so the research objectives, okay, is to prepare Chitosan-based benzaldehyde derivative sorbent materials and to characterize the new Schiff-based sorbents using the available techniques, which is FTIR, XRD, BET, SEM, TGA, and to investigate the sorption performance of the synthesized materials toward toxic ions at different variables from initial ion concentration, pH, contact time, temperature, and sorbent weight, and to analyze the adsorption isotherm by fitting the experimental data with different isotherm models as Langmuir, Friendlich, and Temkin isotherms, and to estimate the kinetics and thermodynamics parameters by applying various kinetic models and Van 't Hoff equation. And the last was elucidation of the maximum sorption capacity of Chitosan benzaldehyde sorbent materials and comparing with other commercial sorbents. The procedure as follows. We did synthesis of the modified Chitosan. Then we characterized the resulting polymers. Then we did preparation for the buffer solutions and the metal ion solutions. Sorry. Then we did the sorption process of the metal ions into the polymer. And the last, we applied the mathematical calculations. Okay. 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 As you can see here, this is the characterization of the polymers. The FTIR give a clue for the formation of the imine group that emphasize the conformation of the Schiff-based compound. I don't know if this is clear or not, the C double bond N, and we can see it clearly between the range of 1,500. Also, the TGA was presented greater degradation temperature, indicating the stability of the modified polymer. Also, we applied another technique, BET, but I didn't present it in the poster because there's no space. But the BET displayed mesoporous materials and great enhancement in the surface area, which was higher than 83.7, that correspond to the polymers than the chitosan itself. Then the XRD also gave a patterns exhibition for the change in the materials with less intensities. And the surface morphology for the SEM, sorry, for the SEM showed altering in the surface. As you can see, the A correspond to chitosan itself. B, C, and D has more roughness and channels in the surface. So this is the difference. And also we take another picture after adsorption. These roughness gone, and what happened is we saw a very smooth surface, which indicates that this adsorption process was happened. Okay. This is for the characterization. When we go to the investigation of the environmental factor, for environmental factor, we did investigation for the pH from the range 3 to 7. And we saw that the best sorption was at medium 5 to 6. And for the adsorbent weight, we started from weight from 0.01 gram until 0.1 gram. And the best sorption of the adsorbent was when the weight is 0.05 till 0.1. Yani these two was the best removal at these weights. For the temperature, we studied temperature from temperature 30 to 70. And we saw that at higher temperature, the adsorption process get very well. For the contact time, we saw fast sorption, like from 5 minutes, 50% of the metal ions, of the concentrations of the metal ions was already uptake. So it was very fast sorption. Also, we studied the isotherms, thermodynamics, and kinetics. These are the modeling studies. These studies predicted the performance of sorption process. For the thermodynamic parameters, delta G illustrated the spontaneity of the process. It was positive. Delta S indicated about the high randomness in the interface between solid solution interface. And delta H was positive, so this was the endothermic reaction in nature. For kinetic studies, we applied pseudo first order and pseudo second order models. And the process was perfectly illustrated by pseudo second order. So it demonstrates that the chemisorption is the rate determining step. What happened in the isotherm studies that we applied Langmuir and Freundlich and Temkin. Langmuir displayed a perfect fitting for the data with the high coefficient values of the two systems, which has suggested formation of monolayer and homogeneous structure. The value QM that taken from the equation of the Langmuir was higher than 125 milligram per gram. And the enhancement on this and on the maximum capacity is owing to the chemical functionalization of the benzaldehyde derivatives, and the uptake also, when we compare between cobalt and nickel, the best system was uptake. The cobalt was very good in the uptake process. This is for the modeling. And here is the conclusion. As we said that the isotherm suggested monolayer coverage with the QM higher than 125 milligram per gram. The values of QM follow the uptake, as we said, cobalt more than nickel. And the uptake kinetic was fast, and chemisorption might be the rate determining step. Thermodynamic provide endothermic, feasible, and high randomness at solid solution interface. And here's the environmental factor, as I said. The pH, the best pH for the uptake was slightly acidic or near neutral medium. Sorry. The dosage was around 0.05 to 0.1. And the temperature found at higher degree, the agitation time was around 8 hours, but there was very fast uptake. And the concentration was at low values. From the obtained result, it can be seen that the prepared biosorbents in the present study displayed noticeable performance for the removal of cobalt and nickel ions, which can be promising candidates for wastewater treatment. Thank you.